Next up, we have Sreenivas and Anahi. They're going to be diving back into the world of cancer, so I'll let them talk about their project.
Thank you. In the year 2030, 21.7 million cancer cases are expected to be diagnosed. This is a disease that is extremely common in the United States and has wreaked havoc on countless lives. Therefore, any treatment that can be given to patients for cancer is of prime importance. However, many treatments have their own host of side effects that can further damage survivability. Cancer is characterized by a loss of cell cycle regulation. The cell cycle is a regulatory of the division of cells. As you can see here, cells will go through a growth and division phase, go through a growth phase, then they'll replicate their DNA, they will grow again, and then they will go through mitosis, in which they split into two identical daughter cells. Cancer cells go through this process extremely quickly, producing more and more cells and producing tumors. Tumors are characterized by loss of tumor suppressor genes, whose job it is to regulate the cell cycle and also to cause cell death in cells that do not meet certain requirements. Loss of those tumor suppressor genes and additional mutations which involve the activation of proto-oncogenes, which become oncogenes and further spur on cell division, cause the growth of malignant tumors. Malignant tumors can metastasize, and cancer cells can spread to other locations in the body, and that can be fatal. Cancer treatments are designed to help destroy tumors or destroy cancer cells around the body. Surgical removal of tumors is effective, since if tumors are the correct size, they can be excised. However, it is completely ineffective if tumors have metastasized, because tumors will continue growing in other parts of the body. That too, tumors are not the right size. Too much of tissue might need to be removed, or if tumors are too small, then it might not be suitable for operation. Radiation therapy is very target specific. It is aimed to destroy tumor cells in a certain area of the body. However, radiation can destroy other healthy cells near the irradiated site, or even furthermore, damage their DNA and turn them into cancer cells, which is ideally something that you try to avoid in a cancer treatment. Chemotherapy, on the other hand, is a treatment that is non-specific. It flows throughout the bloodstream and tries to kill off cancer cells. However, many chemotherapeutics target dividing cells in general, and that can cause a lot of collateral damage. A lot of cancer patients will lose their hair because the quickly dividing cells in their hair follicles tilt. And that too, many patients will develop blood conditions because the quickly dividing cells in their bone marrow are thick. Doxorubicin is a specific chemotherapeutic drug. It is an anthracycline. It functions to destroy cancer cells by inhibiting their cell division. Topoisomerase is a specific enzyme that is used in DNA replication. DNA replication occurs in a process that's similar to pulling apart the strands of the string. That produces a lot of mechanical stress, and topoisomerase essentially splits apart the DNA and glues it back together in a specific order to relieve that mechanical stress. Without topoisomerase, the cell will try to use other mechanisms to do so, and that ends up causing DNA damage. Furthermore, doxorubicin inserts itself into the DNA, specifically between guanine and cytosine. That actually changes the structure of DNA permanently, and it stays there. So cancer cells can't really regulate their own genes. They can't transcribe this, and especially they can't replicate it. So it'll end up killing those off. However, there's a very large side effect associated with doxorubicin treatment, and that's myotoxicity. Doxorubicin is going to kill off muscle cells, and it's going to inhibit their regeneration. Doxorubicin actually promotes the growth of things called free radicals inside cells. Essentially, free oxygen atoms and free iron atoms will be produced, and they will tear apart most of the cell. That too, if the mitochondria within the cell attempts to metabolize the doxorubicin, it cannot perform its original function, cellular respiration. It releases a compound that tells the cell to kill itself. And that overall will contribute to the death of skeletal muscle as well as cardiac muscle. Furthermore, doxorubicin actually downregulates certain myogenic regulatory factors whose job it is to stimulate the production of new muscle. The most important of those myogenic regulatory factors is called MyoD. MyoD regulates all the steps from about differentiation to fusion of satellite cells. Satellite cells reside within a certain part around the muscle called the sarcolemma, and they will migrate inwards the muscle and go over certain steps in which they will form new muscle cells. And then other factors we've been looking at are MRF4, myogenin, and MYF5. MYF5 tells satellite cells to keep producing, keep dividing, so that muscle can produce again in the future. And MRF4 is not especially necessary, but it contributes a role similar to myogenin that tells satellite cells to fuse and finish their differentiation. We wanted to see how doxorubicin treatment affected the concentration of those factors within slow and fast twitch muscle. Slow and fast twitch muscles are two different types of muscle. Fast twitch muscles tires very quickly, and they also produce energy more quickly. Slow twitch muscles are obviously slower, and they also tire much slower. There's two such muscles we're looking at, the soleus, which is a slow twitch muscle in the calf, and then the EDL, which is a fast twitch muscle in around the ankle. Creatine, however, has been shown to promote muscle growth and actually promote myogenic regulatory factors, and it might actually be an effective treatment for doxorubicin muscle wasting. As you can see here, creatine gets put into the cell via its creatine transporter, and in turn, this triggers a pathway in which it upregulates these myogenic regulatory factors, and that's really important. Furthermore, creatine does other things for muscle. Creatine forms creatine phosphate in a specific cycle, and it eventually lets ADP become ATP. ATP is the energy currency of the cell. Muscle cells use a lot of it to trigger muscle contraction, and if creatine phosphate, which is this form of creatine right here, can turn ADP back into ATP relatively quickly, people will tire slower, and they will be able to perform better.
Looking at the hypothesis of our experiment, we included these points. Doxorubicin is expected to deplete the expression of myogenic regulatory factors, which are also known as MRFs, and creatine should increase the levels of all of these factors. So when we're looking at our dox plus creatine, overall we would want to see levels increase because creatine should combat those effects that dox poses on the skeletal muscle. Also, when we're looking at our control, we should have higher levels of MRFs when compared to doxorubicin, because doxorubicin should deplete those MRFs. And our proteins of interest, which are MyoD, or are all MRFs, we will quantify their expression and be able to compare them to one another later on and see how their expression varies. For our procedure, we conducted our procedure in Dr. Hydock's lab, and the rats that we used were Sprague Dolly rats, and each rat had its own compartment, and they had water and food which they were assigned to, and our groups that were assigned were our control of doxorubicin and our control of doxorubicin and creatine, and each one was assigned a specific rat chow to be eaten, and then so doxorubicin and our control were eating a traditional normal rat chow, while creatine had a 3% supplemented chow, which then allowed us to implement the creatine within their diets, and then this allowed it to be within their muscles. So afterwards, they were on this diet for 2 weeks, and after 2 weeks they were injected. Our control group was injected with saline, which was 15 milligrams per kilogram, and our dox and creatine group were injected with doxorubicin, which was the same amount, which was 15 milligrams per kilogram. And then each rat, throughout the process before and post injection, they would actually have mandatory treadmill exercise and hand grips. And in the image right here, you could see that the rat was placed over a stationary object, and they were grabbed onto it, and when their tail was pulled, we were able to quantified the strength that they used, and overall, in the end, we wanted to see that that strength decreased because doxorubicin was affecting the skeletal muscles. So when the rat was injected with doxorubicin, post 5 days, they were sacrificed. They were first anesthetized, and meaning that they were put to sleep, and then in order to continue with the procedure, their tail pinch reflex had to be absent. This means that when Dr. Hydock pinched the tail, we didn't want the rat to have any reaction at all, so that we are able to extract both the EDL and the soleus. So for the methods, once we take out the entire tissue, they are flash frozen in liquid nitrogen and go through homogenization like the protein assay, Western blotting, and fluorescent imaging. So when looking at homogenization, the tissue must be weighed between 0.07 grams and 0.1 grams. And then once it is weighed, it's put into, right here, you can see a mortar and pestle, and then radioimmunoprecipitation, or also known as RIPA, is a buffer used to lyse the cells, which will further help us break down the cell to get to the proteins. And then protease inhibitors are also added to prevent the proteins from denaturing, and we don't want them to denature because we want all the proteins to stay the same and be expressed in the end as they were when they were inside of the rat. And the Brandtburg protein assay standardizes all product protein concentration. So when we take the muscles from the rat, there are different masses, and when there's different masses, there are different possible proteins that are inside of those masses. So if we don't standardize the entire concentration, our result won't be as accurate as we want it to be because there's physically more protein in one sample than the other. And when looking at Western blotting, samples are placed into, but going back to the Brandtburg protein assay, limate is added in order to denature all of our proteins. And this means that they're all now negatively charged for our Western blotting, which is then piped into our gel, which then the gel has an electrical current ran through it. And you can see up in the picture above, the gels have balls up here, and once they are there, the anode will pull and migrate all of the proteins down to the bottom, and it's ran for about 2 hours. And once they are all ran, you will notice that the proteins that are more dense or are longer will be towards the top, and the smaller ones will be towards the bottom. In order to understand this fully, you can take the example of shooting a BB gun through a sponge. If the pellets are larger, then they won't get as far into the sponge as if they were to be smaller. And once that is done, you would want to transfer your proteins onto a membrane. And to do this, you are running an electrical charge again. However, this time the proteins are going to come out of the face of the gel and onto your membrane itself. So you are now making a copy of the gel. And with the membrane, you're able to image through chemiluminescent imaging. And chemiluminescent imaging involves a primary and secondary. Right here, you will see a primary binding to a specific protein, and then the secondary binds to that primary, and we're able to image and when imaging, we're able to see the secondary come up, and which will show us where our protein is on our membrane. And then here you will see that this is the chemiluminescent substrate that we use in order to image, which is placed onto the face of this machine, and it's like developing a film. So you are going to take a photograph of our membrane, and then you will get an image here. And when you are washing your primary and secondary, you have them here, and it's a lengthy process because you have to wash, and then you have water, and then you have your primary again, and there's different solutions that you have to use in order to make sure you go through the entire process.
As you can see here, our results were not exactly very accurate. There was a lot of splotchiness on the images we took. This would negatively impact our results because essentially what we're doing is we're looking for the optical density, or how dark our spots are. If there's giant white splotches where the substrate didn't really get down to the image, that means that that entire spot's going to appear darker, going to appear lighter, and these spots are going to be relatively darker, And if these were in one group and these were another group, we would have results that would say that these had less concentration of a protein, or these had more concentration of protein, which is not something we want to have. We also underwent in our own lab, we saw to label our samples. As you can see here, those were two of our plastic covers on our gels. We wanted to be able to identify exactly which tissue had been put in which well. So after imaging, we could see, which animal had more or less concentration of protein. And as you can see, there are some spots that appear above this main bar right here. That is caused by non-specific binding. If the antibody identifies another protein and somehow latches onto it, that'll produce a little shadow of an image, and that could also affect results if those occur really close to our actual protein. Our results were obtained with the help of a mentor, Mr. Toro, but they were not extremely significant since our p-values were greater than 0.05. As you can see here, in some places, doxorubicin treatment actually increased the concentration of myogenic regulatory factor. And in other spots, you can see here that the creatine and doxorubicin treatment had the intended effect, increase the concentration of a myogenic regulatory factor. But in other spots, they seem to be just about the same, and the control treatment performed better than both experimental groups.
For conclusions and expectations, we saw an upward trend in MyoD and in MERV4 within dox. And doxorubicin stresses the muscle, meaning that when the muscle is stressed via myotoxicity, the body's reaction is to regulate that and induce muscle repair. So that is a possible explanation for why we saw MyoD and MERV increase. However, a decrease in MERV5 and myogenin within dox was seen. We were expecting to see a decrease within all MERVs, and this was because doxorubicin will downregulate all of them. And in the creatine and plus doxorubicin increase, we saw an increase in MERV5 expression. However, it was slightly. We expected to see a significant increase in all of the MERVs when they were treated with creatine as well, since creatine will add a phosphorus to ATP and allow the muscle to regenerate more of those MERVs. For future study sources of error, we had insufficient creatine concentration. We only used 3% in the diets of the rats, and maybe varying that would help it come up more when we are looking at our results. And during the chemoluminescent kit, we observed that it's quite difficult sometimes to get a perfect image. As you guys saw, there was a lot of dark areas, and this is where when you're rolling out the substrate, sometimes you roll too much or too little. And also the antibody age has a lot to do with it. If the antibody is too old, then you are unable to get an image at the end. So the primary would not bind to the protein at all, so meaning your secondary wouldn't bind, and you wouldn't get an image. Also, when you're imaging is the last step, and you don't know where you might have gone wrong. So when you're piping your samples into Western blotting, or when you're transferring, you can't see the proteins at all. So in the last step, when you're imaging, if you don't get an image, you really don't know where or what possibly could have gone wrong. And for results, greater creatine concentration would help us determine if creatine would help counteract the effects of doxorubicin. If we modulate the days post-doxorubicin injection, it would broaden the spectrum of data that we have in order to compare them to one another. And creatine-only group would also help justify that creatine does upregulate the expression of MERVs when doxorubicin downregulates.
We would like to thank our sponsors. My sponsor was Sreenivas, Cell Energy.
And my sponsor was Adolf First Foundation. They sponsored both my room and board and research.
And we'd also like to give special thanks to our mentor, Mr. Zoltan Toro, and we'd also like to give thanks to Mr. David Hydock. Mr. David Hydock and Ms. Raquel Boosters. They helped us in the lab and helped us process our results. And we'd also like to give thanks to Ms. Lord Ball and Ms. Fiorozzi. We don't know if creatine would actually have any adverse effects, but I would imagine that over supplementation of
Oh, it's billing twice?
the circulatory system or liver.
Oh,
Of course,
you should have not clicked once it started. Always refresh before clicking.
You guys talked about measuring grip strength of these mice. Can you re-emphasize why that was important?
So when you're measuring the grip strength before doxorubicin, you will notice that they have more grip strength or a greater force that is applied when you are pulling the tail. So once they are injected with doxorubicin, since doxorubicin does downregulate the MRF expression, meaning that your satellite cells aren't activated in order to replenish the muscle that is now affected, you will have less muscle and it's damaged, so you wouldn't have enough grip strength to hold on for as long. So the rat is physically affected from doxorubicin.
Thanks.
What did MERF stand for again? Like MYF?
Oh, the question was, what do the MERS stand for? They stand for myogenic regulatory factors. They're just the factors that influence the growth of satellite cells and development of new muscle. David?
So you mentioned your creatine concentration is only 3%. I have two questions, I guess. What's the other 97%? Just some binding agent. And then if you're trying to see
You let it compile.
creatine effects, like what effects creatine has in this situation, why wouldn't you just try to do like as high a concentration as possible?
We wanted to, the question was, why didn't we do, what was the...
No, actually what happened is somehow I'm not able to go back to this presentation. It may go out completely, I don't know.
And also...
No, your presentation is okay. What I said is my daughter presenting
If you're
something.
trying to like see how creatine affects
My daughter's not started, I don't know whether it is.
right away, try to use
There is one more presentation. They said my daughter's will be at 11:40 our time, but it's not started.
maximum amount of creatine possible. We wanted to simulate as much as possible
Just
an
to,
actual treatment.
these current presentations, they are almost finishing.
Especially high
So I want to see whether
so we wanted to see exactly if supplemented 3%, exactly what effects it would have. We are considering, if we were doing a further study, we would increase the concentration of creatine that the rats were given, because that would hopefully reduce the intended effects.
so the program they were doing.
That you were able to see proteins
So
and transfer
once
them.
that is done, we will present what they have done.
Something you can put in so that throughout the process you can check whether your protein is transferring. Stuff like
Okay, so after this, my daughter.
One thing we did is we have a ladder. Ladder is essentially
presenting.
it's something that
After that, my daughter will present.
size of a protein.
So they are doing question answer. It's supposed to start at 11:40.
bands. If we look at it and we actually put another one in there, I think it's called Magic Mark, if I'm not, it would actually show up on the gel itself. It was in color, so we could see it, and if we did the transferring correctly, that color would not show up on the membrane, and we would know that we did something wrong there.
Y'all mentioned the grip strength. What effect do you think the rats that were supplemented with creatine, what effect would that have? Do you think that would have on grip strength?
Well, the question was what was the effect of creatine? Could you restate the question, sorry?
What would you think the effect of creatine would be on grip strength if it was given to rats?
What would we think the effect of creatine would be if it was given to rats with grip strength?
Yes.
So, since creatine, we would expect creatine levels to increase the expression of MRFs, myogenic regulatory factors. We would hope to see that creatine would improve the muscle strength of the rat itself. Even when Dox was introduced, then meaning that the factors of doxorubicin were counteracted by creatine.
So then if that was given to say, a human population,
Don't click release twice.
what effect would that have? What effect do you think that would have on patients that receive chemo? If your effect is saying we hope to see an increase in grip strength, what would that do?
The down one is auto started and this one is.
If we observe that it increases the grip strength in rats, we would hope that the patients who are receiving creatine along with their chemotherapeutic, they would lose as much muscle as they would have. And that too, doxorubicin damages heart muscle. So all of a sudden, heart disease becomes a risk factor if people who take doxorubicin. We would want to see that they'd be getting along all right with creatine supplementation because that would upregulate the production of muscle in their heart.
Adding on to what Srini said, the symptoms would also decrease. So when you're on chemotherapy, you aren't feeling too good about doing anything. So then if creatine is upregulating those MRFs, then your muscles will feel better, you will physically feel better and counteract the symptoms that normal chemotherapy has.
She hasn't started yet, just let's finish yours. So it will come.